everyone, I am Jahan A. Minog and I am from Group 7. So, quick question muna. Have you ever wondered kung gaano kaliit ang nanoscale? So, imagine this. If we shrink something 1 billion times smaller than a meter, nandun na tayo sa nanoscale level. So, today, I'll be discussing the distinct features of nanoscale and the fundamentals of nano manufacturing. So, distinct features of nanoscale. So, first, bakit ba special ang nanoscale? So, there are three main features that make nanoscale materials different from normal materials. So, first is the biological scale. So, a lot of the structures inside a living organisms actually exist at the nanoscale. So, for example, DNA is around 2 nanometers wide, and hemoglobin, which is the protein in our blood that carries oxygen, and it is about 5.5 nanometers. So, basically, many important processes inside our body already happen at this tiny scale. So, because of this nanotechnology is very useful in biology and medicine. So, scientists can design nanoscale tools or particles that interact directly with cells and molecules. So, for example, there are nano particles being developed that can deliver medicine directly to specific cells, which can make treatments more targeted and effective. Next one is the quantum effects dominate. So, this is the second feature, the quantum effect. So, normally, materials follow the usual laws of physics. But when materials become extremely small, quantum physics starts to dominate. So, meaning their properties can suddenly change. So, simple. An example is gold. So, we usually think gold as yellow, right? So, but when gold becomes nano size, it can actually appear red or purple. So this happens because the behavior of electrons changes at a very small sizes. So which affect the properties like colors, electrical conductivity, and magnetism. So at the nanoscale, materials don't always behave the way we expect. The last one is the very high surface area. So, when materials are broken into extremely tiny particles, their surface area increases a lot compared to their sizes. An example is, as you can see to the slide 1, cubic centimeter of 1 nanometer cubes can have around 6,000 square meters of surface area. So, that's huge considering how the small material is. So, because if this large surface area, nanoscale materials become much more effective. This is why they are useful in things like chemical reactions, batteries, medicine, and environmental technology. So, to summarize the distinct features of nanoscale, the quantum effects become stronger and the surface area becomes larger. The nanoscale overlaps with important biological structures. So that is why studying nanoscale material is very important in modern science. The next one for my topics is the fundamentals of nano manufacturing. So the next question is, if nanoscale materials are that small, how do scientists actually create them? Right? So there are two main approaches they use. The first one is the top-down fabrication. So in this method, scientists start with a bigger material when they cut, trim, or shape it down until it becomes nanoscale. So you can imagine it like carving a sculpture from a block of wood. You start something big, then remove parts until you get the final structure. But one disadvantage of this method is that sometimes some materials are wasted during the cutting process. So an example of techniques used in this methods include the nano imprint technology, the molecular beam epitaxy, and roll-to-roll processing. Also, the atomic layer deposition. The second one is the bottom-up fabrication. So, instead of starting big, shrinking it down, this method builds structures atom by atom or molecule by molecule. So, instead of carving, it's more like building something using Lego blocks, diba? So, small pieces come together until they form a bigger structure. Some example is the deep pen lithography, the self-assembly, and the chemical vapor deposition, or the CVD. So, this method is very useful because it allows scientists to create a very precise nanoscale structures. So, why these two are important? So, these two approaches are considered the foundation of nano manufacturing. So, the top-down focuses on reducing material to nanoscale, while the bottom-up focuses on building structures from atoms and molecules. So, using this method, scientists can create nanoscale materials used in many industries like electronics, medicine, energy, and environmental technology. So, that's all for my part. Once again, I am Jahan A. Minok from the Group 7. Thank you for listening.
Have nanotechnology products. One of the example of nanotechnology product that was used during the pre-modern era was medieval stained glass. So in this particular window, there has been already nanotechnology invention. No, hindi lang nila alam yun, pero nagagawa na pala nila. They can manipulate things in a nanoscale such as this one, medieval stained glass. Kaya nagkakaroon ng color because some elements or chemicals inside of it is in a nanoscale. So this one medieval window stained glass is the one of the first nanotechnologies in the world and discovered. So it shows no na yung nanotechnology is matagal nang ginagamit even before modern science. Because kaya nitong i-change ang properties ng material gamit yung nanoscale. So first, let's talk about biomaterials. Bio means life, materials means a state of matter. So these nanobiomaterials are being used in healthcare such as imaging tools, as bioengineering to detect diseases. So it means they can manipulate things in medical field. They can diagnose cancer, HIV, and other diseases. So this is a good example of biomaterials because they are using tools to diagnose those diseases and also to treat those illness. Yung COVID-19, ginamitan di ba nila ng biomaterials tools to detect that particular disease. So yun, nanotechnology is ginagamit sa biomaterials para makagawa ng mas accurate and of course, mabilis na diagnosis and at the same time, mas effective na treatment. Since nga kayang i-manipulate ang materials sa nanoscale para makipag-interact sa cells and of course, DNA. Of course, we have ceramics. An example of this is nanoceramics paint coating. This is being used as a car paint coating to provide strong protection and shield that keeps the paint of the car to look shiny and brand new. So, if you could see, kung makikita mo yung chemical na yun, there's already added elements with that particular chemical that can provide strong protection and keeps the paint of the car looks shiny. Kung kaya makikita mo yung ceramic paint coating is sobrang kinis nun because of that nanotechnology in the coating chemicals. Kasi sa sobrang limit nung chemical niya is pinoprotect niya yung coating ng car. Hindi yan siya basta-basta nadudumi or madudumihan or mawawala yung pagka-shiny niya because of that chemical in a nanoscale that's protect the car. Next, we have polymers. These have been used to enhance and strengthen computer chips, especially its design. Kasi nga, di ba, sa first generation computer, napakalaki, no? 200 square meter ang sinasakop, but today, they can manipulate thing in a nanoscale. Kaya nga, di ba, kung mapapansin nyo, yung mga cellphones natin is very manipis na, yung mga laptops natin, television is very manipis na din. So, again and again, yun, they can manipulate thing in a nanoscale which can be compared to a size of DNA. We have also commercial application of nanomaterials. First, we have sunscreen. This sunscreen provide protection from harmful UV rays of solar radiation. These have been possible through the use of nano-sized zinc oxide that reflects and absorbs UV rays and made it ultraviolet resistant. So, this particular sunscreen has a nano-sized zinc oxide that protect your skin from harmful UV rays from the sun. Chemical engineers did this, chemical scientists, sila yung naka-invent which help our skin from the harmful effect of UV rays. So, kasi 'di ba kapag masyado kang bilad sa araw without using it, pwede ma-burn yung skin mo and it might affect your health. Another one is we have cleaning window. So as you can see on the left side of the window, it's an ordinary window. It's not self-cleaning window. Kasi on the right side, you can see self-cleaning window. Of course, it breaks down the dirt and stain repellent fibers that can be washed away by rain. Kasi nga sa sobrang smooth niya in a nanoscale, it has also chemical on it. Hindi lumulubog yung certain chemical. For instance, kapag ang bagay ay may mga halimbawa butas-butas, hindi siya tingin mo ba kapag kinapitan niya ng another thing like such as water or another thing, it can be liquid, dudulas na siya? Hindi, kasi nga rough siya. If something is so smooth, another thing will slip away. Sa sobrang smooth niya using nanotechnology, sa sobrang smooth niya using nanotechnology is dumudulas na lang yung dirt and yung tubig, making it self-cleaning window. So, saan ba usually makikita yung self-cleaning windows? Usually, makikita siya sa mataas na buildings kasi for example, 100 floors mataas yun na building. So, kapag hindi siya self-cleaning window, is gagastos ka pa para lang palinisan yung window mo. Kaya siya na-invent para sa mga buildings rather na matataas. Nanotechnology applications, a variety of uses. So first, we have in medicine. So MIT researchers design nanoparticles that can quickly locate a tumor, then set off a chemical reaction that attracts swarms of drug delivering nanoparticles to the site. So in the field of medicine, yung MIT daw, kapag nakapag-invent sila ng nanobot na nakakapag-locate ng isang tumor, so nagpro-produce sila ng chemical reaction para kumbaga mag-react doon sa tumor. So imagine lang na isang robot, pero kumbaga pinaliit lang siya ng very very small size, tas in-inject siya doon sa katawan natin. So yun, tapos yun yung purpose niya is to detect yung mga tumors. So yun yung application niya na isa sa medical science. Of course, we have in electronics, nanomaterials like graphene and cellulosic nanomaterials are being used for various types of flexible electronics. So, are you guys familiar dun sa Samsung na phone and Samsung Z Clip? So, sabi nila bendable glass daw yun siya. But actually, it's not really a glass talaga. Hindi siya purely glass kasi there is a glass with a mix of plastic. So, basically, nabebend mo kahit papaano, pero hindi siya yung pure na glass kasi kapag finold mo yung pure na glass is malamang mababasag yun siya. So they have to apply some plastic. So if you guys search the video of Jerry Ricks sa YouTube, so isa siyang YouTuber na nagte-test ng phone. So tinest niyang gasgasan yung screen. So sa level 2 pa lang is gasgas na yung screen ng phone, yung foldable na part ng Z Clip. So yung gitnang part doon is made of plastic, pero may glass din daw doon sa loob. So, yun yung kumbaga isa sa application ni nanoscience is kinombine niya yung particles ng glass and plastic. Next, we have fuel cells. A nanoparticle coating on this disc increases 8-fold its current best performance. So, basically, coating lang siya, parang ina-envelope lang niya yung fuel cell sa loob para hindi siya, para ma-prevent yung exfoliating.